Pero I don't finish, no matter.
Okay.
I don't finish. Okay, entonces you identification number 1 que es cardioide when the number is the same 2, 2, 3, 3, 4, 4, right? Of course, if you have 3, the cardioid is bigger, right? It's bigger. However, you have the possibility that the number is different. Suppose R equal to, or 2, no, 3. Let me use 3. 3 plus 2 cosine. Okay, this number is different, but A is bigger than B. Entonces Limacón without inner loop. Entonces el Limacón look like an apple, something, you know. But the orientation, okay, let me try it again. Specifically, this one is positive, entonces in that direction, something like that, right? Because it's positive. Open to the right. Entonces, you see que 3 and 2 is different. Entonces, si es the same, es 2 es cardioide, si es no. Okay. This is la que R 3 plus 2 cosine, ¿no? Suppose que es negative, entonces R equal 3 minus 2 cosine. It's the same Limacón, but open in the opposite direction, no? It's like that. Let me try to do my best. And don't worry too much for this. You know, you can memorize it because you put in decimals, it's obvious, and you get the answer. However, you need to interpretation. This answer is correct or no. Well, decimal never make a mistake. However, you make a mistake because you forgot something in the equation. So now you need to interpretation. So at least you have to get some idea how you expect. Suppose this one que es positive, pero sign. Entonces, like that. The dimension depends on the number, right? The dimension depends on the number. And finally is 3 minus 2 sine is down. Down. Let me try to do my best. Something like that. Make sense? Limacón without inner loop. Cardioide. And now what about Limacón? So far everyone follow me?
Yes, Professor. The difference between is that the cardio, it touches like the zero axis, right?
Very, very well. Touch the passing through the 0, 0, the pole. Now we have another possibility que es suppose que we have R equal to plus 3 cosine. In this case, A is less than B, no? B, A is 2, B is 3. Entonces we have the famous, this is Limacón also, with inner loop. And the inner loop is, let me try to do my best, no? After you see in this one, the answer. Okay, this is plus cosine case in that way. So you have is something like that, push. However, we have inner loop. Okay, I try to do my best. Look like that, passing through the origin, but doing the inner loop. This is the R equal 2 times R equal 2 plus 3 times cosine theta. CS R equal 2 minus 3 cosine theta is to the left. It's the same stupid thing, but to the left. So let me try to do my best. Okay, pero es a ver, no, sí es en opposite direction. Passing through the origins, yes. Okay, is here origin, pero no, no, in that direction. No, I am doing it wrong. Okay, it's exactly flip it. Let me use my imagination. But not like that, sino like that. Entonces we have, okay, something like that. No. Oh, carajo. But I don't know. You see en Desmos. Suppose sine. Sine is r equal 2 plus 3 times sine. So you see, wow, es limacon within a loop because a is smaller now. Entonces is something like that. Let me see. In a loop is this. Wait. Entonces no in the direction. In a loop is like that. Is something like that. Wow. In a loop in this direction. Okay, entonces now the rest is like that. Okay, this is r equal to minus 3 sine theta. Let me try to do this one. In a loop is this direction. Okay, opening this approximately. Guys. Do you understand the idea? So it's super easy. Recognize cardioid or limacon. When the number is the same, it's cardioid. When the number is different, it's limacon. Depending who is bigger, A or B, we have inner loop or without inner. Clear? Clear. Answer me.
Yes, Professor. Can I take a picture?
Well, after I explain the rows. But no, copy that. Take a picture.
Okay. Thank you, Professor.
And the rows is relatively easy to identification because we have r equals something or sine or cosine. Suppose cosine, que es easy. And you have coefficients. You have coefficients, maybe 2, 3, 4, 5. That depending of the size of petal. 2, si es 3 is big petal, no? Cosine, and your identification, because inside the trigonometric function we have multiple. So we have maybe 2 theta, or 3 theta, or 4 theta. So this is the rows. Now, when it's cosine, suppose que es 2, we have 4 petals. Here, 1, 2, 3, and 4, something like that. When this, the number coefficient is even, the number of petals is equal twice that number. When it's 3, no. When it's 3, no. When it's 3, you have 3 petals. 1, 2, and 3 petals. This is what n equal to, and this is what n is equal to. And when a sine is similar, except it rotate a little bit. In this case, rotate 45 degrees, like that. The same amount of petal, but rotate something. In this case, rotate 45 degrees. In other case, it's more complicated. So rotate maybe another angle. Okay, this is the rows idea. So the red one is sine, and the black is the cosine. And that's it. You need to memorize this information. Just in case, no. I don't know. We analyze, you let me know what is the option that you consider correct. When I did the review package, I see that there are mistakes. O sea, in the answer, you need to choose their mistake. However, no problem, because we fixed the mistake because I plot in Desmond, no? Desmond always give me the truth. No? For example, in number 8, let me make it zoom to see more clear. The page number 8. What do you think? ¿Es cardioide o limacón? O rose? Cardioide, limacón o rose? Identification, guys. Look in the question.
I think is limacon with inner loop.
No, Noela. See, A and B is the same number.
Yeah, you're right.
And then, what is the conclusion? Come on, guys, another participation. Not only Noela. Come on, another participation. What do you think? What do you think?
Yeah, I don't know how to pronounce that.
Cardioide. And this is the cardio center in the hospital. Que is about the heart. Cardioide. Ese cardioide, right? Entonces, pero en what direction open? Up, down, right, left?
It's B, Professor.
It's B, Professor. Very well. Who said that? Who are you, Miss?
Haley.
Haley, identify que es cardioide open up. Okay, B. Option B. Any question? Do you see or no? Okay.
I have a question. I want to understand what is the difference between like the limacon and the cardiology. I know the one touches and the other one doesn't touch it.
I remember that you say me. Cardioide, look, is touch the origin. And limacon, no?
But what about with the inner loop, Professor? This is the one that I didn't understand.
Okay, inner loop is something like that. Suppose the same problem, sign, positive. Inner loop is something like that. Inner loop. No inner loop. And cardioide. Clear or no?
It's clear, Professor, but the thing that I didn't understand, like when we have for example, R2 plus something, how are we gonna identify if it has like inner loop or doesn't have inner loop?
No, it's easy. Look, see the number in the middle. Suppose this 3 minus 2 minus or plus sign. This is this. Because this number is bigger than this number. And suppose now 2 plus 3 sine theta equal R, of course. We are talking about R. This is this. And this is that, because it's the same 2. More clear now?
Now it's clear. Thank you so much, Professor.
Okay. Don't forget. This is B. Okay, so done. No. I double checking, no? How are we double checking? How? Checking in Desmond, no?
Yes.
Okay, let's do it. I copy the equation. Do you see Desmond?
Yes.
Boom. Look at that.
Professor, I have a question.
Go ahead.
When we have on the test, can we put on Desmond's and send it to you, or can we just like circle the option?
No. In the test, we have no options.
Yeah, I forgot.
Entonces now you are doing Desmos and you send me the picture. But the problem is, suppose that you put in the Desmos and you put incorrect by mistake, I don't know, and you get completely different. So you need to know what answer you expect. You see what, immediately I see that, I identify que es cardioide, que open up. That's it. That's it. That's it. I suppose, I don't know, how do you take calculus? You forgot this. The regular student. Okay, let me try to do my best. At least I try the intention. Do you want I do by hand? Suppose when the student have no Desmos, or when the student have no Desmos, some student in the other decade before this, 10 years before this, using graphic calculator, and this graphic calculator is too expensive. Allow us to plot the in polar. Let me try to do at least this example by hand. Guys, we have time. The problem is that you understand very well, and something recording not in YouTube, you know, in your memory about that problem, about this problem and another problem in trigonometry. Suppose this. Suppose that I have no anything, only my brain to analyze this. Okay, so I recommend doing in this way. Suppose theta. And theta is 0 degree. I prefer degree, no? 90 degree, 180 degree, 270 degree, and we return to 360 que es 0. And we compute R in each scenario. Entonces, 2 plus 2
Desmos.
Ay, sorry, 3 times. Carajo. Okay. Wait a second. Okay. Okay. Carajo. It's complicated for me, that part. This is that?
Yes.
Okay. Entonces, you make a decision. Maybe we need to find another angle in between this. But suppose the base is 0, is this guy. 0, 90, 180, 270, and one entire revolution is 360, no? And you plug it in. Sine 0, I know que es 0. I need to remember. Entonces, it's 2. When I plot that, let me try here, plot. That point in polar is the point r, theta is 2,0 degree. And 2,0 degree is here, 1, 2. This is x-axis, is the y-axis. Make sense? 90 degree. Well, 90 degree is different. It's 2 plus 2 sine 90 degree. And sine 90 degree is 1, and 2 plus 2 is 4. And the point is 4,90 degree. And 4,90 degree, remember, 90 degree is that angle. Okay, and you put 4 at the radius. Entonces, 1, 2, 3, 4. Entonces, this is the point for 90 degree in polar, but in Cartesian is 0,4. Entonces, our cardioid look like that. Oh, do you see that? Suppose 180, curiosity. 2 plus 2 sine 180. Sine 180 is 0. Second is 2, pero es 2,180 degree. 180 degree is that angle in that direction, and 2 radio in this direction. This point is the same, 2. 270. 2 plus 2 sine 270 degree, que es -1. Sin es -1, entonces es 0. Wow, es 0. Es 0, es 0. O sea, that point is 0,270 degrees. And I suppose que the part, que es the last part, es el de ángulo in between 270 and 360. And 360 is exactly the same as 0, so we return to this. Do you understand this or no? It's super easy. Do you understand? Well, at least to do a roughly stupid sketch to have some idea how it look like. Okay, any question?
No questions, Professor. Can we do in that way when we're gonna do the test, or it's better to put in Desmos?
Okay. No, both. Because Desmos Nuela es double checking.
Okay.
Okay?
Okay. Can I take a picture?
Well, let me finish to take a picture.
Okay.
2 plus sine 360, sorry. Okay, of course the answer is exactly the same of this, no? 2. And it's a 2,360 degree. And we come back to the famous point origin. So the trajectory look like that. This, and that one. The trajectory. Take a picture now.
Okay, I took it. Thank you, Professor.
Entonces, I delete this page. Okay. For me, this is important, guys, because when you take calculus, the teacher of the calculus, okay, by the way, is calculus 2. Okay. The number 9 question is R equal 3 minus 2 sine theta. And remember the identification, cardioid, limacon. What do you think? You remember? You don't remember? I need to explain again or no?
It's limacon, Professor.
Limacon, but what kind? Without inner loop or with inner loop?
Without.
Without. Very well. In what direction is oriented? Upward, downward, left, right?
Down.
Left.
No, because es sine. Si es cosine, negative, entonces I agree que es left. Pero si es sine, es down. O sea, si es sine, we have two possibilities, north or south. Si es cosine, you have two possibilities, east or west, right, left. Okay? In this case, es negative. So, agua lima con... Que hay a mistake here. Let's double check in Desmos. Agua lima con look like, in my opinion, like that. Let me see, something like that, no? Something. It's the orange or the apple, I don't know, like that, and open down. Entonces I don't see anything that look like similar to this. That is a reason that this option is wrong. Yeah, I want to prove in Desmos, but no, you want, let's do in the graph again by hand, using the table. Do you want? Or let's go directly to Desmos?
You can do the graph, Professor, so we can see.
Okay, super. This is intuition, guys, because I memorize when the number is different, el limacon, and when the A is bigger than B, remember this number is A, and this number is B, el limacon without inner loop, and also when it's negative sign, the orientation is down. Okay, let's try to do. This is theta, and we're using the classical. Maybe you need to create another, but no, at the beginning I don't know. Entonces I suppose 0, suppose 90, suppose 180, suppose 270, and we come back to 360, no? I'm plugging in my expression que es 3 minus 2 sine theta. And we get the point in polar. R, theta. Entonces es 3 minus 2 sin 0. Sin 0 es 0. And 0 times 2 es 0. Entonces the answer is 3. The point is 3,0 degree. ¿Qué I suppose is this guy? 3,0 degree. In polar. Remember, in polar, you are doing first of all the theta part and after the radio. Now, theta 0 means on the x-axis, no? Entonces on the x-axis and 3 units. 1, 2, 3. This distance 3. This distance, of course, is symmetrical. I did wrong, no? I did wrong. Let me try to do my best. This is 3. 1, 2, 3. Okay. 90 degree. 90 degree is 3 minus 2 sine 90 degree. Sine 90 degree es 1. Entonces 1 times 2 es 2, negative 2, 3 minus 2 es 1. And the point is the point 1,90 degree. And 1,90 degree is here. 1,90 degree. 90 degree, when you talk about 90 degree, is on the y-axis. 0 degree is on the x-axis. Our lima con, I don't know, look like that. Now 180, que is in the opposite direction, is 3 minus 2 sine 180 degree. Sine 180 degree and sine the 0 is the same. It's 3. It's 3,180 degree. Okay, entonces 1, 2, 3. 1, 2, 3, but in opposite direction. That point is 3,180 degree in polar. In Cartesian, you know, is negative 3,0. This is xy, no? But I don't care Cartesian now. Okay, entonces our lima con approximately look like that. I don't know exactly what's going on here. I need to see the part and that's more clear. And 170 degree is important part, I suppose. It's 3 minus 2 sine 270 degree. And sine 270 degree is negative 1. Entonces negative 1 and negative 2 is positive 2 and 3 is 5. Okay, entonces the point is the point 5,270 degree. Entonces 1, 2, 3, 4, and 5. Wow, fantastic our Limaco. I like this Limaco. And 360, now instead of plugging in, the answer is the same. Entonces 3,360. And we come back at the beginning. This figure always is closed figure. Do you see this clear?
Yes, it's clear.
I don't see any option. I don't see any option to satisfy this condition, no? No? No option to satisfy this condition because it's in a loop, no in a loop, pero es left. Entonces, that means que the teacher que doing this study guide, I copy with the back of the problem or make a mistake or don't do anything about that part, right? Just in case to make sure que I'm doing well, I put in the decimals, no? Let's do it in decimals now. Do you see this one, right?
Right.
Question 9 is 3 minus 2 sine. Boom. Look at that. In green color. Do you see?
Yes.
This point is 3. This point is 1. This point is negative 3. This point is 5. Nice. I understand very well polar. This is the idea for the review, guys. In the lecture, maybe I am doing too fast. I send to you PowerPoint. You see or you don't see. Okay, now this is a moment to, you know, organize your brain and to see in detail that part. Okay, I come back to the whiteboard. Okay, entonces now in the test you don't need to select anything. No, the test is no multiple choice. Entonces I can delete that page. I can erase that page. You took a picture or no? Nuela?
Yes, Professor. Thank you. I took.
Okay. Okay, next page. Que is 10, ¿no? You see the whiteboard, right?
Right.
Let me try to find the page. Uy, where the hell? Okay, over there. This page. No, this page. We have another page before that page. Okay, number 10, and it's 11. Okay, identification. Identification. We have R equal 2 minus 3 cosine theta, right? Identification. Cardioide lemagón, inner loop, no inner loop. Orientation. In what direction? Go ahead.
It's on left.
To left. The orientation, Noela, say que es to the left. How do you know que es to the left, Noela?
Because it's negative and it's cosine.
O sea, ¿es el lemagón o el cardioide?
It's lemagón.
El lemagón, to the left. Y sí say que es to the left. And have inner loop or no?
Yes, it does, because 2 is smaller than 3.
Entonces, the loop is like that, ¿no? The loop is in opposite direction, ¿no? Let's see. Yeah, I am crazy. Because it's to the left, no?
Yes.
I don't know. I don't do by hand a little bit. Like that? You believe?
Yeah, yes, is what I believe.
Okay. It's important belief. Entonces, in this case, also we have no option because this is without inner loop. Look, no good. And this is with inner loop, but this is go down and this is go right. And our problem is left. So this is wrong. This is the problem. Don't frustrate for this. This is doing for people. And the people suppose que no, pero is in the organization copy wrong. Oh, I don't know. I don't care. I care, do well. Okay? Well, it's a little bit complicated doing in the table. Do you want to try?
Not really, Professor.
No, we can. Look, let me show you. Let's try. See, I cannot, bueno, I cannot, I am human also, no? Is theta. In this case, I suppose that we need to split more this. But I have no idea. Suppose 0 degree, suppose 90 degree, suppose 180 degree, suppose 270 degree, and we come back to the 360. And the formula is R equal 2 minus 3 cosine theta. And we have a point en polar r como theta. Entonces es 2 minus 3 cosine 0. Cosine 0 es 1. Entonces es negative 1. Es negative 3. Okay, it's negative 1. But the point is negative 1, 0. I don't know si this point, let's see after, is this point. I believe it's this point. Let me see in my Desmos sketch. Absolutely, it's this point. You don't see now, but I promise I see. It's this point. 0 degree. Wow, pero professor, 0 degree is in this direction, no? But the radius is negative. And remember, it's 0 degree in the right direction, but negative flip it to the other direction. Do you see that?
Yeah.
Okay. Okay. Makes sense so far. 90 degree. 2 minus 3 cosine 90 degree. Cosine 90 degree is 0. The answer is 2. And the angle is 2, 90 degree. And 90 degree to 90 degree is that one. This value is 2. This distance is 2. This distance is 1. This distance is 2. 180. 180 is 2 minus 3 cosine. Cosine 180. Cosine 180 is negative 1. And negative 1 and negative 3. It is 5. It's 5, 180. I suppose que this point is this point. This distance is 5. Do you see que make sense? O sea, yes. So far, the motion, we start here. I suppose que we travel in this direction. We continue travel. Suppose que you want to understand that part, you select another angle, for example, 30 degree, 45 degree, 60 degree, and you are doing exactly the same of this. Entonces now, I don't know exactly what is this point. I don't know. What is 0? Well, but it's easy to understand. Maybe it's no fundamental angle. It's a one crazy angle. We continue to travel this and stop here 180. No, si you continue 270 is in this direction. Que es obvio que es the same answer of the 90 degree because cosine 270 degree is equal 0, exactly the same cosine 90 degree. 2 minus 3 times cosine 270 degree. The answer is 2. Entonces es 2,270 degree. Okay, entonces this point is this one. And 360, I suppose que is equal this. We come back to this. Now, would be fantastic. Determine this point. What theta corresponding with this point? Well, the only possibility is suppose que this equation 2 minus 3 cosine theta equals 0, no? Con the radius 0, and you solve this equation. Unfortunately, this angle is not fundamental, okay, you know very well that 90, 60, 45 is 2 equal 3 cosine theta divided by 3 both sides, 2/3 is equal cosine theta, and theta is equal cosine inverse of 2/3. Let me compute it in my calculator, pero this is curiosity. Es cosine inverse. No yet. Okay, escape. Cosine inverse of 2/3. 2 divided by 3. Express it in degree. This answer because I want to show you in degree. Present is 40, 40, 40, 40, 48. 48 point something. 48.18 degree. Is 0. 0 radian. Do you understand the trajectory? 0, 90, 180, 270, and 360 come back to this. And I discovered that this angle is 48.18 degree. Right?
Right, Professor.
Excellent. You know that. You know trigonometry to understand this. Okay. Now, don't worry for this. The idea is that you see at least one time in your life how we are doing the graph of this by hand. However, I double check in decimal, but I expect without do anything. Neither the table. Look in this. I saw que es Lima con with inner loop and open to the left. End the story. Now, and decimals. Do you see?
Yes.
End the story. End the
So,
story.
on the test, Professor, because we know the theory, can we just put it that it opens on left, on right, or like
Using intuitive idea. Intuitive idea.
okay.
This is the way I want. So when I start today the lecture, I want to explain without table. Pero you enforce you, Nuela, to understand better, okay? And you need to come back again to the intuitive idea. Okay?
I see, Professor, because for
okay. You push me, yeah, I push you.
Okay, Professor.
Okay, number 11. Let me take advantage that we are in Desmos. Somebody say something extra? Some students? Come on, don't be shy. This is a moment to understand very well this part. Because I take advantage that we have in Desmos, no? Entonces now you see, do the graph of the R equal 4 sine 2 theta. Entonces, when you say 2 theta, entonces es a rose. How many petals? 4 petals. Look at that. 4 petals. And rotate 45 degrees because it's sine. Si es cosine, rotate, no rotate. 0 degree. And we can do, if you want, the table again, but no necessary. Okay. This is question 11.
Yes, Professor Petal, right?
Let me come by. Yeah. But let me see this is right or wrong. Okay. This I finished that. Delete. And also I delete that part. Okay, was the limagón with inner loop. Question 11 was a rose, no? A rose. What option you select? A, B, C, or D?
Professor, I can see it because we still in Desmos.
Okay. Sorry. I always forgot that part. Okay. Come on. Let me know.
It's A.
Is it? Obviously. Very well. Any question on the flower?
Can I just stop? No questions. It's 4 because it's 2 inside, right, Professor?
Yes. Okay. Yes. Entonces, remember, when there's even number, the amount of petal of the rose is twice. 2 times 2, 4. Okay?
Okay, I got it. Thank you.
Okay. Let's move on to another topic. It's about the complex number, complex and polar. Okay, number 12 question say, write the complex number in polar form. Okay, it's given in rectangular, -5 minus 5i. I would like you write in polar. Polar, remember, is R cosine I sine theta. Do you remember that? And the formula is easy. R is equal square root x squared plus y squared and theta, you know, is approximately tangent inverse. Approximately, no. The problem is that you apply the formula, but you adjust the sign according to the quadrant. So that's super, 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 super important. Do the graph of this complex number in the complex plane. Even the complex plane is the plane that is a real number here, an imaginary number here. It's not the classical x and y, no, no. Then negative 5, negative 5. Negative 5, negative 5 is 1, 2, 3, 4, 5. Negative 5 and down 5. 1, 2, 3, 4, 5. Negative 5i. So our complex number lie here. Let me show you in the other column. Like a vector. No, exactly. Some people prefer this way to show this, pero no, es a point. Entonces es obvio que es lie in the third quadrant, correct? Third quadrant. Entonces my angle theta que I want to expect lie in the third quadrant. Okay, let's do in the easy part, que es the radio. The radio part is easy. It's square root 5 square. Well, actually it's negative 5 square. I don't care the negative because it's square positive. It comes positive and negative 5 square. 25, 25 get 50. And leave it like that, or simplification a little bit, it's a 5 radical 2. Because you know 50 is 225 when you find the square root. I know very well the square root 25 5 and radical 2 stay inside the radical, no? However, when you divide tangent inverse of negative 5 divided by negative 5, es obvio que es tangent inverse of positive 1. So you believe, wow, I know very well que es pi over 4. No, because pi over 4 lies in the first quadrant. Actually, es in the third quadrant. Entonces, in the third quadrant is 225 degrees or 5, no? 5 pi over 4. Now, let me see. Oh, they want in degree. So forget about the radians. The answer is 225 degrees because I know que tangent, you know que tangent 225 degrees is 1, and also it's equal tangent 45 degrees. Entonces, this is the couple of the angle that have the same value of the tangent. But it's important identification the position of the complex number to understand what quadrant you select, what angle you select, see in the first quadrant or in the third quadrant. This idea is confusing or clear?
Professor, it's a little bit confusing because I didn't understand why it lays on third quadrant.
No. Yes. Because the real part is negative 5, Noela. So it's this segment. And the imaginary part is negative 5i, is this segment. Now the combination, these two numbers, real and imaginary, give me this complex number. And this complex number, the angle expressed in polar, lie in the third quadrant, que is 225 degrees. Makes sense or no?
It makes sense, thank you.
Another question. Entonces, I can select something. What option you select? A, B, C, or D?
C.
Excellent. Remember, guys, I put in the paper because I want to condense this. 5 radical 2 cosine I sine 225 degrees. But you know that this is equivalent to say cosine like that, I like that, and sine. This is the acronym, no? To condense this information. So far, it's good or no?
It's good.
Beautiful. Let's do it now, number 13. Okay. 13 is, wow. The number 13 is negative 6. Negative 6 means Okay, we have no imaginary part. If you want to understand more clear, you put 0i, but this is not necessary. So you are doing the sketch. It's important, do the sketch always. Si you don't do the sketch, you are lost. This number is here. Let me show you here. And that distance is -6. And the angle is this. Okay, by the way, is 180 degrees, no? Theta is equal 180 degrees. And it's obvious that the R is the distance from the pole to the vector, no, to the specific point. Can you plot? Therefore, the conversion in polar is 6 positive. Cosine I sine 180 degrees. Without doing anything, using intuition, only intuition. If you want, I prove mathematically. Let me know.
I think intuition is fine. Intuition is fine.
Yeah, intuition, I like intuition. When you have quadrant angle, 0, 90, 180, 270, and 360. In my opinion, it's better. Why? Because suppose I don't know anything. You say you try using the formula. R is equal square root x squared plus y squared. Who is x? X is -6 squared, and y is 0 squared. You know? It's obvious 6, you know, because -6 squared is 36. 36 plus 0 is 36. Square root 36 is 6. So you take always the positive solution. Now, the angle is a complicated part because it's tangent inversa. Tangent inversa is always hard of the y gets 0 divided by -6. Entonces 0 divided by -6 es 0. Tangent inversa es 0. Entonces, bueno, what's the angle whose tangent is 0? Well, there are a lot of 0 degree is possible, but 180 is also positive. And what you take 180 because the number is negative. It's one possibility. Okay. However, another double checking is suppose que I expand this guy like that. 6 cosine 180 plus I sine 180. Cosine 180 and -1. Sine 180 is 0. That means that we have no imaginary part and the real part is -6. And we come back at the beginning. It's a backward. No in these directions, you know, in opposite direction. Super clear?
Yes, can I take a picture, Professor?
Take a picture. Entonces, wait, what option you help me to select? A, B, C, D?
Okay, can you zoom it, Professor?
Yeah.
No, Professor, now I can see it because you zoom it like the page.
Okay. You want to see?
Yeah, like that? I already took a picture, Professor. I just want to see it like, because you asked about like the okay, let me see.
It's good for you, this position?
Yes, it's good. Thank you, Professor.
Entonces, what option you help me to select? A, B, C, or D?
A.
Super. We are the best in Miami-Dade College, right?
Yes.
Yeah, absolutely. I told you. Okay, now I did that page. Okay. Now 14, huh? 14. 14. 14. Well, 14 is similar. 14 is the complex number que es 6i. It's a pure imaginary number, no real part. So si it's not real, you can suppose that this is equal 0 plus 6i. Makes sense, right? And remember, this is the x component, and this is the y component. Intuition. No mathematics, no formula, intuition. When it's quadrantal, this is the real axis, real, and this is the imaginary axis. And this number is in the imaginary part here, 6 units. The distance is 6. And the angle is 90 degrees. Makes sense, right? When you convert to this, from this to this, we have 6 cosine I sine 90 degrees. Make sense?
Yes.
Double checking. This is equivalent to say 6 parenthesis cosine 90 degree plus I sine 90 degree. Cosine 90 degree is 0. Sine 90 degree is 1. 1 times I is I, 6I. We come back at the beginning in opposite direction. Is the option C, no? Obviously.
Yes. Can I take a picture, Professor?
Yeah.
Thank you.
How do you feel in that part?
Good.
Good. Conversion, one complex number from rectangular to polar. Okay, now solving this problem. So in this problem, we have different situation. We have two complex number, no? Two complex number is given. Suppose C is equal A cosine I sine pi over 6. Okay, and W is 3 times cosine I sine pi over 2. And they want you find multiplication. So C times W. Entonces, what is the formula? What is the formula that we are using to multiplication? Multiplication is you have two complex numbers. Suppose the first complex number is R1 cosine I sine theta 1. Multiplication R2 cosine I sine theta 2. When you perform the multiplication, you multiply the radius. That the new radius is R1 times R2. This is my new R cosine and sine, and my new theta is the sum, theta 1 plus theta 2. This is theta of the new complex numbers. So it's super easy. It's multiplication. This guy times this guy get 24 cosine I sine, and you adding pi over 6 plus pi over 2. Okay, is 24 cosine I sine. We are working with the radio, unfortunately, no problema. This is least common denominator que es 6, es pi plus 3 pi, no? Es 4 pi over 6, que when you reduce in lowest term is 2 pi over 3. 2 pi over 3. So you are doing in degree, this is 30 degree, this is 90 degree, and together 120 degree. And they want you leave it like that or convert to... No, leave it like that. Leave it like that. Let me show you. Leave it like that because the answer is expressed also in polar. The answer is also expressed in polar. Okay, so you want to convert to rectangular, well, so you expand cosine I sine. But no, they want in polar. That's it, end the story. So what option you help me to select? A, B, C, or D?
Sorry, Professor, can I take a picture?
However, I asked something, but option is the correct. A, B, C, or D? Do you want to make a zoom to the page?
Yes.
Is it D?
D, absolutely. What is the student that always get the answer correct? What your name is?
Nora.
Nora. Okay, Nora. Any question? Multiplication, super easy, the formula. Multiply the radio and add in the angle. Okay, multiplication, multiplication, multiplication. 3 problems on the multiplication and no division, okay? I respect that. Okay, one more and that's it. Stop and we continue. Remember, now, next day, it's Thursday, we continue doing the review. I suppose to finish. Therefore, you know, okay, then the test will be due, the reading test online. I need to fix it next day, next Tuesday, next Tuesday, next Tuesday. And next Tuesday is 26, no? 26, yeah, 19 plus 3. Next Tuesday, do test number 4. And 28 is do the final for the student can make a decision to take the final. Totally optional, it's up to you. Guys, I don't want delayed. So you don't send to me, I don't care. So you put the wrong email. I don't understand this. Some student send me the test number 1 correct, 2 correct, and 3 wrong. Because I do, however, when you communicate with me, the email is correct. So I don't understand. I'm stupid. I'm not stupid. Okay, one more and that's it. Okay. Number 16, no? Okay, 16 is C, complex number is 6. Cosine I sine, the theta is 3 pi over 2. Okay, and W is 12 cosine I sine 5, no? 5 pi over 6. Okay, they want you to compare exactly the same multiplication. And multiplication is easy. C times W is multiplication 6 times 12 is 72. Cosine I sine, and you adding 3 pi over 2 plus 5 pi over 6. Okay, let's do it. Least common denominator is obvious 6. 6 divided by 2 is 3, 3 times 3 is 9 pi. Plus 5 pi because it's the same number, no? The same denominator, that's 14. Pi over 6. We can reduce, of course, we can reduce. At least divided by 2 is 7 pi over 6. 7 pi over 3. Because 14 divided by 2 is 7 and 6 divided by 2 is 3. Okay, but 7 pi over 3 is bigger than 2 pi, no? Because 7 divided by 3, so you put it, for example, you put in the calculator 7 divided by 3 is 2 point something, 2.3. Entonces, I need to 7 pi over 3, entonces, entonces, I need to find the coterminal angle in the classical 4 quadrant. No, this is 1 revolution. This is 1 revolution and a little bit more, I don't know exactly. You're subtracting 7 pi over 3 minus 2 pi. In order to decrease in 1 revolution, no? So the LCD is 3, is 7 pi, minus 6 pi. Entonces es pi over 3, ok. Entonces 7 pi over 3 es 1 revolution, que es 2 pi, plus pi over 3. O sea, no here, es exactly 60 degrees. Here. Ok, entonces actually, my angle is not 7 pi over 3. It's ridiculous. When you put 7 pi over 3, it's correct, pero no, it's not correct. Entonces 72 cosine I sine pi over 3. Get the option. Okay, option what? What option? B, no? Me? Nora?
Yes.
Okay. Let's stop because I have another class right now. Well, we continue. You have the test. Working. You continue working in the homework and test online. Everything is due. Number 4, April 26. Okay, and April 28, done. The course is over. Any question? What part you don't understand very well? Come on, come on, come on.
Professor, are you going to the Turing tomorrow?
Yeah, of course.
Okay.
Okay, guys.
Still there at 11, right, Professor?
11 to 4.
Okay, thank you so much.
Thank you, Professor.
Bye.